Well, it's been more than a year since I last posted a video, and I've been up to a lot since then, but alas, it is Corona time, and so now I have the availability to make and animate the long-awaited second video of the D&D Science series. Let's jump right into the nitty-gritty. Dragons, they're the most iconic and arguably the most dangerous D&D enemy. They're even in the name of the game. But beyond the massive size, claws, wings, and flight speed, their most dangerous attack is definitively the breath weapon. Depending on the species, it appears in cones, lines, and features different damage types. In most editions, it is so devastating that the monster has to recharge it before using it again. Today, we will ask the question, how dangerous might the breath weapon actually be in the real world? Let's set some ground rules as always. We're using numbers from 5th edition, always use averages on dice roll numbers, and we withhold the right to throw our hands up into the air and say, magic? Let's start with the metric of an ancient red dragon's breath weapon, which deals an average of 91 fire damage on a failed save over a 90-foot cone, which equates to 1.91 times 10 to the 5th square feet. For explosions, the simplest measurable conversion point of force would be dynamite, which deals, according to content, an average of 9 explosion-based damage to a spherical 523 square feet around it. Time for some not-so-quick maths. So you would think that it would be as simple as just converting the damage to force, but unfortunately, the damage isn't allocated over the same square footage, so we have to go from megajoules in sphere form to cone form, and then from there convert megajoules to damage again. With real-world dynamite producing an average of 1 megajoule of energy per stick, using conversion from force per square foot in a 5-foot sphere to that of a 90-foot cone, we can then convert the force to damage by setting the values equal to each other. Thus, we can finally determine that for every foot of exposure in our ancient red dragon's cone, this poor adventurer would receive 0.0277 megajoules of force per square foot. But this crispy individual is more than likely medium size, so they're not just getting exposed to 1 square foot, they're getting exposed to at least 5 square feet, so the force gets multiplied by 5 respectively. When converting to more recognizable units, that's 102,000 pounds of force. And so, just to give some perspective, that's like getting punched by a skilled martial artist whose fists are on fire 325 times in 6 seconds. So now, using this new metric, let's circle back and check our work by bringing in the same forces in terms of D&D. The study we used for Punchy Force used the average of 12 karate black belts, which, when consulting with my gauntlet of DMs, we all agreed to say that it was fair that a karate black belt might be about a level 1 monk, probably with a 12 to 13 in strength, maybe a little higher if they were a diligent weight trainer as well. So just doing some simple calculations using 5e abilities, that would mean that with each punch, our monk would be dealing an average of 3 damage a strike. So even without any bonuses for fire or burning or anything like that, we did our explosion calculations purely based on force. That's 325 times 3, so 975 damage total, which is, 10 times what even the strongest dragon's breath weapon deals. Based on this, in my mind, the biggest metric for inaccuracy that our calculations demonstrate is that in D&D, punches for a monk using unarmed weapons have to be scaled up really high and even become magical eventually. So that's probably more damage than they would be in the real world. So we're resorting to our magic clause here. But that seems like a video for another day. Thanks for watching, and let me know what you think the next analysis should be in the comments. Stay safe, everyone.